The equation y equals 2 minus 3x square defines a function f with y as dependent variable and x as an independent variable. Using the function notation, we would write y equals f of x, or briefly we write f of x equals 2 minus 3x square in order to minimize the number of the symbols. Okay, by this way we don't write the y. But generally we write the y equals 2 minus 3x square. So in the equation y equals 2 minus 3x square, y is dependent variable, okay, and at the same time function. So I mean sometimes we write this is y of x, okay. So this is covalent notation, and no harm is done as long as one is aware of the double role of y. Other examples we can give other examples. Other examples are x equals 3t square minus 2t square minus 3t plus 1. Z equals square root u square minus 3u. Here this is x of t function. That is z of u function. Or we can give some other example. Okay? According to your textbook I wrote. So x square minus 3s to power 2 over 3. Okay, this is the r of s. So until now we have considered the function involving only one independent variable. But there is no reason to stop that point. This concept can be generalized to function involving two or more independent variables. And we will do this case in the second term in second term of this course in the chapter 7. Okay. So now we will okay, your textbook says borrow. We will borrow the notation of the function involving two independent variables. Actually, two variable functions. Let's write f of xy, for example, x square minus 2xy plus 3y square minus 5. This is two variable function. Two variable. In the second term, we will discuss this one. Okay. Sometimes we need the two variable functions, actually two variable equations. Okay. For example, this is an equation. This is equation. If we write as the f of x form, this is a function. Okay. So this is very related with each other. This is a function. So two variable function can be given as a equation. I mean, for example, 3x squared plus y minus 2 equals 0. Okay, this is the equation. From here, easily you can obtain the y. Y is the 2 minus 3x squared. So you can sketch the graph, etc. Because this equation describes a function. So, but sometimes some equation don't describe a function. For example, x squared plus y squared equals 1. Everybody knows this is the graph of this equation is circle, unit circle, okay? But it is not a function. This is equation. But y cannot be written as a function of the x, okay? Let's emphasize from here, y cannot be written as a function of x. But on the other hand, we can consider the tangent line of this curve. So what is the tangent line of this curve? How you can calculate tangent line of this curve? You need the slope. So you need the derivative of the y at the point x0. Okay, or y prime of x0. So So to overcome this problem, we talk about the implicit differentiation. Okay, why it's called implicit? Actually, here here 3x squared plus y minus 2 equals 0 is given implicitly, but y equals 2 minus 2x squared is given explicitly. Okay, so we have an explicit, this means directly stated rule that enable us to determine y for each value of the x. On the other hand, the y in the equation 3x squared plus y minus 2 is the same y as in the equation y equals 2 minus 3x squared, or the function 2 minus 3x squared, but it is given implicitly. Okay, so 3x squared plus y minus 2 equals 3 given implicitly. Using an equation that defines a function implicitly, to find the derivative of the function is called implicit differentiation. How we differentiate implicitly? Let's try to explain. 3x squared plus y minus 2 equals 0. So we think that y is a function of the x. Actually, hiddenly we know y is a function of the x. So we differentiate the equation in terms of the x, okay? But by applying the chain rule, here we assume y is a function of the x. So what we have, derivative of the 3x squared is 3 times 2x, derivative of the y is y prime. So y prime minus the derivative of 2 is 0. Right hand side is 0. Actually, we take the derivative of the right hand side also, but derivative of 0 is 0, so this is 0. So from here we obtain y prime equals minus 6x. Okay, actually you can verify easily because y is the 2 minus 3x squared. So from there this is minus 6x. Okay, easily you can verify. So in general, when we have the some implicit function, okay, by borrowing the two variable function notation, okay, for example, let's say 3x squared plus ln y plus x times y equals 2. I don't know if it's logical or not. Okay, anyway, for this function, how you can calculate the y prime? So by differentiating the both sides in terms of the x, you can calculate. Of course, by using the chain rule, you can calculate. Sometimes you may need the other rules, product rule, quotient rule, etc. So derivative of left hand side 6x plus derivative of ln y is 1 over y because of derivative of the ln by the chain rule times derivative of the y. Plus, by using the product rule, derivative of the x is 1 times second function y plus first function times derivative of the second function. And right hand side is 0. So from here, you can obtain the y prime. So by taking y prime common factor of parentheses 1 over y plus x, on the other side minus 6x minus y. So this implies y prime is minus 6x minus y over 1 over y plus x. Okay, so this is the derivative of the y. Since y is given implicitly, y is given implicitly, the derivative of the y can be included to both variable x and the y. This is normal for us. Okay, so by this idea, you can calculate the derivative of the implicit function. So what you do, you differentiate in terms of the equation. You differentiate the equation with respect to x, and when you see the function y, you consider y is a function of the x. So by using the derivative of the y, if you need, you can use chain rule, product rule, quotient rule, etc. You will be calculate the derivative of the y from the equation.